we have some
Botero.
some paintings. Yes, if I put one of these image, you begin to find only Botero.
Yeah, because at this
Picture.
point, it in the first time it could not capture the style, but in the second example, when you put the image, I like a lot the flexibility of this demo. And please, in order to show the viewers of this video that the semantical power is not just men and women and so forth, the classic example, could you please search pop minus red?
I found only Pope white
Exactly.
dressed.
White dressed popes. Hi everybody. Today it's this video is a bit special because I am here with my friend Vincenzo Agrillo, which was one of the very first users of vector sets, which are the new data type of Redis that I implemented recently in the recent months and are useful in order to do vector search. However, while many use cases that we every day see with vectors that are all about RAG, which is retrieval augmented generation, Vincenzo is focusing in something that, in my opinion, can be extremely interesting. That is semantic search of images. We all know that there are new embedding models in recent years that are able to produce embeddings, compatible embeddings with the same meaning in the same space between image and text. And Vincenzo is using such embeddings for prototype, for a proof of concept for a customer. So welcome here, Vincenzo, and thanks for joining us in this video. And please tell us something about you.
Thank you, Salvatore. I'm Vincenzo. I'm here. I'm honored to be in this video. I'm a passionate technician. I am over half a century old problem solver. I work for since 95 with a Sicilian company that now it's in Messina, in Padua, and in Rome. We have in our years worked in so many technologies. My main work is data center administration. We have 2 data centers. But I love programming, I love information technology. And so with the hype of AI, I cannot be out of this technology. In our work, in our services, for our customers, we have to manage so many artistic heritage. One of our main customers is Italian Catholic Church, and now we have a new pope. For this customer, we manage the assessment, the asset of cultural heritage. We have in our DB, in our data center, nearly 15 millions of asset of item that we need to archive, to describe, and so on. In the last month, in this year, because it's now near an year of AI revolution, we search for some application, some solution for our customers. We explored the RAG solution. Nearly 1 year ago, I began to use some solution RAG-based. We need to use on-premise solution. So for my work on data center, I studied how to host this service on our data center. I can show you. I'm searching for the word Pope.
It looks like it's the news of the moment.
Yes.
Oh, how many Pope?
So actually, I can actually found the Pope. To find the Pope, I write Pope. Then I make a post request to web server. The web server, where there is a Python script built by DeepSeek, programmed by DeepSeek, that use the CLIP model to embed the vector. Then I pass this vector to vsim command to Redis, and I have the top key results. I can search not only by text, because of the model, it is a multimodal model. So the vector is in the same space. The vector of the text and the vector of the image is in the same space. It's 512 elements. It's a vector of 512 elements, and it's in the same space for image and for the text. So I can search text versus images. And so I can search for an image. This is the new Pope. And as you can see, it's instantly.
Yeah, it's a pretty standard pop, I guess.
And as you can see, the speed is brutal. I think if we don't have this speed, we can do it. We can't do this project because we need speed.
You know, it's very interesting what you said about cropping just part of the image. I can imagine that after the search that you just did, I would, for example, zoom in a given exactly or over of the results, and then it changes in a very significant way, because cropping makes it just makes he just a man, no longer a Pope. And
yes. But there is a but. Together, I'm saying it together, we found that with this kind of model, with this kind of vector, arithmetics works very well. So I can add to the query, search for a face like this person. If I ask you, I need the Pope, there is a parameter, so 1/2 it's this face, 1/2 is a Pope.
Okay.
He found something similar, someone looking similar in the face as someone that is a Pope.
Yeah, indeed. Very interesting.
I studied a little bit, I read a little bit about arithmetics of vector, and I found some theory that tell me that king plus woman less minus man, it's a queen.
Exactly. This is a very known example made with the Google embeddings called Word2Vec. But one thing is Word2Vec, it is extremely interesting and surprising that it can work with a model like Clip.
So I put for one king, for -1 man, and so it's having some trouble, some dub, and then I put a woman. I found the queens.
Exactly. So that's a very fantastic explanation of the vector mathematics and how it works in different vector spaces, not just the symbol vectors in Word2Vec. And indeed, it's very cool. You know, normally the way we talked when you were doing this work, we talked about re-ranking basically as an
Yes.
alternative way to do something like I want an image similar to that, but not very similar to this one. So basically, the two approaches are: one is to find vectors that, for example, 1000 vectors similar to something, and then re-rank such vectors to be not similar to something like that. However, while this is the standard of the industry, it's different than globally searching for things that are particularly similar to something and particularly far from something else, because you
Yes.
are limiting the second re-ranking. It's limited to just a very small subset of the elements that you captured.
Yes, yes. And so I, in the future, could use the scalar attribute of vectors that you introduced in Redis.
Oh,
Actually,
okay.
I'm not using it, but I think we will need it. Think about the age, the author, or something similar. About the author, maybe one system like this can. We have some
Botero.
some paintings. Yes, if I put one of these image, you begin to find only Botero.
Yeah, because at this
Picture.
point, it in the first time it could not capture the style, but in the second example, when you put the image, I like a lot the flexibility of this demo. And please, in order to show the viewers of this video that the semantical power is not just men and women and so forth, the classic example, could you please search pop minus red?
I found only Pope white
Exactly.
dressed.
White dressed pops. Completely,
Yes,
some pop is completely white dressed. Awesome.
yes.
That's so
I don't
powerful.
know if they are Pope. I'm not so sure, but
Yeah,
maybe in the model Pope it's similar to priest.
yeah, that's
No,
possible.
it's not a priest.
It's a different, it's a different
Yes,
set of images indeed.
I think it's about the hat.
A
If
very important thing, a very important thing that
I
probably.
they
Okay,
lose the hat.
without the hat,
Yes,
but this is you already searched, so it's impossible to find many pops without the hat, basically.
yes, yes.
Please, can you try something? Even if you basically try to reduce the score of the pop and still use -1 for the hat, just reduce the score of the pop to
As
the
you can see,
point.
it's real time.
Okay, at some point, to be pop is less important, and it is more important to don't have a hat. So it shows.
Yes, but in this case, it's not even a human because
Yeah,
it's
yeah.
minus hat and
Yeah, indeed. There is to find the right spot. Exactly. That's
Or
the
maybe I can ask you painting or if a search status. No, it doesn't work.
what you could do is right now the maximum that you can subtract is minus one, but
Yes.
potentially it could go like minus two. One important thing is that you explained me. I asked this because it is very important. Okay, so think at this. If I, for example, have a pop and I subtract from the pop vector the man vector, I believe that in the vector space, pop and man will have very similar signatures. They are nearby in the vector space because the pop is a man, and so there are many features that are shared. So one problem with this is that we first normalize the vectors and then perform the mathematical the mathematic among the vectors. The result will be basically to zero completely the certain features because they are too similar across the two vectors. And if I do A minus B, I get nothing in certain components of my vector.
But I think the religious part will remain. So
Exactly, but thanks to the fact that you subtract, do the vector mathematic before normalization, also the man will have stronger components in the components associated with mens. So even if I subtract pop, likely they remain there.
I'm trying. I hope I will find a known, but I cannot.
Yeah, it
I
becomes
can try
more.
with this another hack.
Exactly, you can do that. Yeah, at this point, it will not show anymore
Yes, I think,
men or whatever they are. They are.
but I cannot find noon. I don't know how many noon are in this data set. I'm not. No,
Yeah, there are, but
no,
probably
there are.
for the model, a pop is a very specific thing, and it cannot give it away in any way. One thing that I believe it could be interesting is to do the vector mathematic in a different way. Basically, the components that are too many similar are frozen, are preserved, and are not changed. Basically, don't play in the game, and are just maybe averaged. And we do the mathematic only in the remaining components. That could be interesting in order to avoid but nullifying too much certain components. But it's there is to test to see if it makes sense or not.
I will give you another preview of a product that I'm testing. Mm,
Oh, so those are videos.
yes, yes. Let me search punire.
Punire. Yeah, it's a very used verb inside the
No,
chat.
no, no. I sample. It's too small.
I
Look at
santi.
this.
Yeah. So
I
you
searched the
extracted
Santi. The clip
you extract.
model extracted the text.
Wow, that's incredible.
Unfortunately, in this data set, I cannot find some text. Maybe.
Yeah, it has some text understanding because clip is also do you remember the initial image synthesis models that used the Gaussian noise and then denoised the image in multiple steps, diffusion models basically.
Yes.
Uh, uh, and they initially used the clip and they could do some text even if broken. So indeed, there must be inside the clip this ability somewhat.
Yes, yes. Before the end, I want to show you some interesting things. I have this king and this king. I give 1 and -1.
Oh, that's interesting.
I found the man a similar style, and from these two images, he found the style.
That's
Could be,
super interesting.
it could be used in order to find unknown artistic heritage.
Super interesting because
It's another scenarios.
yeah, that's incredible. Basically, since they both are kings, when you subtract, what's left is just the features, the difference of the features among the two basically faces.
Yes,
Super
I'm
cool.
working on this, but it's something very interesting.
Yeah. I think likewise.
I've also, with the help of DeepSeek, I also make this calculator to show vector arithmetics. So in the first example, we know king minus man plus woman. The vector of king is this. The vector of man is this. The vector woman is this.
Yeah.
If I add king minus man plus woman, I have this. At this moment, I take the color for the component that are similar. So the face is more similar to the red one. The second with the blue one, and so on. It's
Yeah.
only to see if this image will give me some information. I'm not so sure that it give me some information, but these results, it's an interesting information. So I found the queen searching for king.
Yeah, I believe that also the vector gives you some information because of the sparsity that you see. Basically, all the colors are more or less represented with the same percentage, which is an indication of the fact that it's working to isolate components. Also, we see that certain components are strong enough and are almost as strong as they were in the original image. For example, the first minus 0.230 in the red vector has a similar magnitude. It's minus 0.226 because in the
Yes.
other two it's a small component. It's a very non-significative.
It's a small component and it's similar.
Yeah,
Man, the first parameter in man it's similar to woman. I don't know what does it mean, but
yeah,
yes,
yeah.
but if
It's impossible to interpret just a single component per se.
yes, but I have a problem regarding this argument, extracting the feature, the similarities. it's because it's not this only parameter, but it's the direction of the vectors.
Exactly, because the vector it's for example even in the 2D space, just a single component. Imagine that you have in 2D space many clusters, okay, many cluster
Yes.
of items. A single component, the X, doesn't tell you anything without the epsilon associated to it. So basically the single components are completely meaningless.
Yes, and it's a problem to identify which are. But you can play, I think, with a similar feature. We have to study. I've done some tests doing a little bit of mathematics, masking some parts of an image and doing subtraction, but I cannot find interesting results at this moment.
Yeah, it's a very interesting thing to discover, and to also to search for old papers and new papers that worked with vectors to extract practical and interesting things from this kind of stuff.
Yes,
Anyway,
will
very
be
very
done.
interesting, absolutely interesting.
I I think we've gone very long.
Yeah, but okay, I will cut a bit maybe the video, but it's okay. So thank you, Vincenzo, for your contribution. I believe this is very interesting and shows in very practical way that vectors are there is to study, to experiment with what's possible with them, and
Yes,
even uh, what is still a proof of concept is interesting enough to stimulate further work on this direction.
I think I need to find other area that is not image or text and image. I'm thinking about other scenarios where this works too. I will let
You,
you know if I found
you,
one.
yeah, sure. You will. I bet that you will find. So I'm showing again your camera in order for the final greetings. Thank you, and have a nice night. In Italy, it's late now. It's 10 p.m.
Yes, I have to check my mail to find if there are problems, there are alerts for our data center because we have this moment is the highest spike of web access to our data center
Oh, so it's
because
possible that there are issues. Okay.
the, the
Thank
phone
you.
remains the phone remains mute, so there weren't particular
remember
issues.
remember to send me the video registration of this. Thanks.
Okay, thank you.
Bye bye.
Bye.